Hello everyone and welcome to another Fusion 360 Live. My name is Brad Tallis. On the keyboard I have my friend Angelo Juris, and today we're going to be doing part 10 of the pencil sharpener assembly. When we first started, I never thought this was going to be a 10-part series, but it's been quite fun and it's been a pleasure seeing how much all of you have enjoyed this series. Today we're going to kind of focus on fixing a couple little issues where we left off last time. We noticed that there was a gear that was kind of clashing with something else, and as we go through the series today, you're going to see a couple more issues arise and how we're going to solve those. With that said, I'm about halfway through. I'm going to purposely make another mistake to show how would we fix this down the road. So I know a lot of you are like, oh, you know, he's on the wrong plane or something like that. Just sit back and watch. We're going to purposely make a mistake and then see how to fix that. So let's dive in. So like I mentioned last time, we left off, we created all of these gears with the relations so they actually work together. But when we did that, we noticed that this main gear is kind of clashing with the post of this lower gear. So we're going to end up fixing that. The other thing I noticed is that the gears actually cover up some of these post holes right here and here. So we're going to have to figure out how to resolve that also. Okay. So what I want to do, oh, and really quick, again, I usually create an outline. I've included it in the description of this live stream. It'll be out on the YouTube video. I've also included some drawings that we're going to be using, so feel free to grab those after the video. Okay, so I'm going to start by, we're working on this motor gear assembly, so I'm going to start by activating this motor gear assembly, because notice how simple my timeline is down here compared to if I had the whole assembly active. And what I want to do is find the sketch that kind of defines all of the, in fact, I'm going to activate this component here, which makes it even simpler. This is just focusing on the base, where this was the whole assembly with all of the gears, etc. So we're going to do just the base, and I can expand that open and see the sketches. If I kind of hover over these sketches, I can see, it kind of flashes on the screen what they're related to. So that's kind of the outside boundary. This one I can kind of see defines a lot of the locations of the holes and stuff. And then this one is what we use to create this little standoff. So I can see that this is the sketch that I want to edit. Now, one of the cool things about this, I'm going to go ahead and turn this on, is I'm in 3D right now. I'm going to right click and say show dimension, and you'll see that it actually displays the dimensions from that sketch. So I don't even have to physically edit the sketch. I can do it kind of here in 3D, and here's why I think this is really cool. So this is sketch 2. I'm going to go ahead and edit sketch 2, and you'll see when I do that, it goes back in time to that sketch, and so you can see all of my gears have turned off or whatever because they actually haven't been created yet. But by, let me turn this guy back on again, by displaying the dimensions on my sketch, I can see all of my parts, and that's going to kind of come into play here. In fact, I'm going to rotate, kind of look at it this direction, like so. Okay, so I'm going to kind of zoom up here. So what I want to do is I basically want to move the position of this post right here so it's a little bit farther away from the gear. So I can see right here is this 0.44 dimensions. I'm going to just double click on it. And again, I'm not editing the sketch per se, I'm actually editing the dimension from the sketch. So let's just crank it up just a little bit. Let's try maybe like 0.46. And when I say okay, notice what happened. And this is what is so cool about parametric design, is I positioned, I changed the dimension of where that hole is located and everything related to it. So the shaft Let me rotate 3D. So the shaft of the gear and even the gear itself moved also. And this is, I think, just amazing, where we can go, you know, we're way late in our design. We're way down near the finish line of our design, and we need to come in and make some changes, and it's actually going to update everything for us. So I also want to, it looks like it's still probably going to hit ever so slightly there. So maybe I'm going to push it down just a little bit. So instead of 0.51, let's just try 0.52. And sure enough, that looks like that's going to give us the clearance that we're going to need. In fact, I can grab these gears and rotate it and see that sure enough, I now have the clearance that I want. And I didn't really have to move this gear too far away, okay? However, by doing this, you'll notice that it kind of changed how the teeth engage right here. So what I want to do is find the revolute joint for that middle gear, and I think I have, let me see, yep, there it is right there. You can kind of see it. It's kind of hard to see with the gray, but I'm going to right click on that and say edit joint. And what this is going to allow me to do is, like we showed last time, we kind of came in and did some angles to kind of rotate this a little bit. So I'm just going to go, let's try 2. Okay, that looks pretty good, but maybe too far. Let's try 2.5. That looks pretty good. So I'm gonna just say like 2.6, and so now I can see that those teeth are now engaged again. So once again, I just went in and edited my revolute joint type, and just went in and kind of edited that number a little bit. And then same thing with this one here. I'll edit this joint, and I can see it's pretty close. That's 1.8. Let's just try 1. Okay, that's the wrong way. So let's try 2. Let's go 2. I don't know, 2.3. That looks good. Okay, so I can just kind of really quickly edit those joint angles to kind of fix all of those to engage. And honestly, they don't have to engage. It's more the relationship of them rotating. But just for visual, I like to make sure it looks good. Okay, hopefully everything is going good here. Just a second. I lost my YouTube feed. Hopefully, Angelo, if you can tell me that everything is going okay really quick through a message. Okay, so let's move on here. So the other thing I pointed out is that these gears cover up the, okay, Angelo, thank you. They cover up these mounting holes. And in fact, if I turn on this gear housing, let me turn on the gear housing. I'll turn off this guy here. We can see that there's these posts that come down, and you can sure enough see that they're obviously clashing with these gears. Okay, so we're going to have to fix this. So I want to turn on and activate the gear housing. So I already turned it on. I'm going to go ahead and activate this. So it's my current component. And then let's go ahead and open its sketches folder. And we can see a bunch of sketches in there. And I'm going to do the exact same thing. I'm going to kind of hover over all of these. And I know from when we designed this, the last thing we did were these posts. So sure enough, if I hover over sketch 8, I can kind of see the locations for that sketch. So I'm going to turn that on. And I'm going to do the exact same thing. I'm going to say show dimensions. And we can see here that it displays the dimensions for these whole locations. Now I can come in and kind of tweak with these. And like I mentioned before in my last live stream, some of you are asking, like, how do I measure these parts? And I just use the digital calipers, and a lot of it is guesswork. I'm just kind of trying to get as close as I can. This is a prime example where I was pretty far off. In fact, I actually have a feeling I flipped it or something like that. But we're going to fix it. Okay, so let's change this. Let's work on this guy right here first. And I'm going to change that so it comes down just a little bit. So 0.5, let's just try 0.6. I'll hit enter. And just like before, we're going to see that everything related to that is going to update. Now you'll notice it took a little bit longer because it's going through quite a few things and updating where that is located, projections, etc. But now if I rotate slightly, we can see that that standoff is now no longer clashing with that gear. But the standoff, the holes, the drill through hole, everything still lines up. In fact, there's even, it's kind of hard to tell, but there's a plastic standoff right here that this post fits down into. That's what you're seeing right here. Pretty cool, I think. Okay, so let's change the, let's do this guy here. Now this one's going to be a little bit more of a change because it's obviously like right in the middle of one of these gears. So I'm going to reposition it, and I don't think there's enough room over here, so I'm going to move it up into this quadrant area up here. So let's change that from, let's see, I'm just looking at my notes here, to 0.15. So I'm going to change this to 0.15, and you should see it move over. Sure enough, it did. And then I'm going to change this one to move it up a little bit, 1.05, and I'll show you on the drawing where I get this from. And so I just went from basically over here to up here, and again I'll rotate in 3D, and we can see that that post, the standoff, the holes, everything updated accordingly. So if I turn off this gear assembly, we can see there's the new locations of the posts. If I turn on the gear assembly and turn off the gear housing, we can see the new location for those holes. And obviously we have enough clearance here and all that kind of stuff. You can kind of see that from the side right there. So a really easy fix. Just by going back and editing the dimensions of the sketch. And again, the point I want to iterate here is I didn't have to go and edit the physical sketch itself. I was able to turn the dimensions on using the show dimension and hide dimension right here. I find this really, really, really useful. Okay, so literally in just a couple minutes we fixed some major issues with the design. So now our gears match and everything like that, or they don't clash anymore. Okay, so what I want to do now, let's turn off the motor gear assembly. Okay, I did that. Sorry, just following my notes. Turn on and activate the gear motor assembly. So I'm going to activate that, make sure it's turned on. I'm going to turn off this gear housing because what we're going to do now is, since we kind of fixed the top of the part, we're going to start working on the bottom side of the part. I'm also going to turn off that sketch just to kind of get it out of the way. So the next thing I want to do is we're going to position a motor. We're going to create a motor here. Let me turn on my camera here real quick so you can kind of see there's a screw attached to it because it's magnetized. We're going to do this motor and these little standoffs here. So I went out to McMaster Car. I went into our parts library, so insert McMaster Car. There wasn't anything that worked. There wasn't anything in this manufacturer part library either. So what I ended up doing is I went out to GrabCAD. So this is a free library where people upload, cars and Arduinos, anything you can think of, switches, etc. So I know I need a 6-volt, I'm going to just do a search for like a mini DC motor. And if anybody has created any of these, they'll upload them and you can see all of the different ones that are in here. This is a great way of getting models, instead of having to create an Arduino board or something like that, or a NEMA 17 stepper motor, you can just come out here and search for it. I like the looks of this one because it has the little gear on there, so I'm going to click on that. And then I'm going to say download files. Now you'll notice there's step and IGES, so here's a step file, etc. So to save time, I've already downloaded it. And I came over here and I said upload, and there's the mini brushed motor. So I just uploaded the file I downloaded and brought it into my project. So I'm going to insert this into my current design. So I'm just going to right mouse click and say insert into current design. And again, like I mentioned, this is a really great way of getting pre-existing models into your design. Now you'll notice it came in. I'm going to rotate it so it's vertical. So I'm going to just do something like this so we can see it's at 90 degrees. And then I'm just going to kind of position it off to the side for now. We don't really need to put it in place quite yet. So I'm just going to go ahead and say OK. Okay, and then I'll minimize this guy a little bit. So I want to work on the motor gear base. So I now have the motor, and we want to position it in a certain location. So I'm going to again make sure my motor gear base is active. So here's the steps required to create that plastic part that you see right here. And then I'm going to just create a quick sketch. And let's see, I'm going to kind of look where I want the motor to be. I'm going to kind of put it in this area right here. So I'm just going to start by drawing a circle. And I'm going to make it 0.24 in diameter. So now what I want to do is locate it. I want to constrain it with a dimension. So I'm just going to say over here, I want it to be 0.065, and down I'm going to say 0.7, and you'll see it'll locate the circle there. Then I can use that to cut through my model. So I'm going to say extrude. I like to start to drag to kind of define the direction. Okay. Now notice if I go too far, if I just kind of drag, it's cutting through my gears. So I need to be really careful. So instead of doing a distance, I'm going to say go to object. I'm going to click this top face, and it's going to extrude whatever it needs to, extrude cut the correct distance. It's going to extrude to this top face right there. And there we go. Okay. Let's see how this is going. Now what I want to do is position this motor in that hole. So what I can do is if I kind of scroll down here, you'll see that this came in, and you'll notice this little link. That means I inserted it into my current design, and if I wanted to, I could go and edit this in a different window and it would update in this window, but we're not going to edit it quite yet. I want to move this whole thing, so I'm going to right mouse click and say move. Now I could create a joint. I'm just showing another different way that you can move something. So I'm moving this whole motor, and there's an option in here called point to point. So I can come in and I'm going to grab this bottom edge right here. So it basically sits on top of this flat face. So I'm going to grab that edge, and it's hard to see, but it grabbed the center of it. And then the target point, I'm going to come in here and click right there. And now we can see that it brought the motor in. It's actually kind of hard to tell, but it's sitting flush with this face right here, and it's perfectly lined up with that hole. And you can see, a little hard to see, there's a little bit of clearance all the way around, so you can see it from there to there, for example. So it's perfectly lined up. So this is a quick way especially if this is going to be a rigid component. I don't have to use a joint every single time. Now the other cool thing is I'm still in my move command. I can come in here and say rotate, and then I can pick like a circular edge, and that's going to allow me to rotate this whole motor assembly. So I'm going to rotate it. I'm going to go positive, and I'm just going to put it like at 75 degrees or something like that. So it's at some angle. So you can kind of see it looks kind of like it's at an angle, for example. Okay, and that just allows me to get a little bit of clearance if need be. Okay, so I now have this motor positioned where I want it to be. Now we can see that the gear that they used is barely meshing with ours, so we're going to end up fixing that here in just a moment. But what I want to do now is these, I can still move this. If I grab this case, you'll notice that these are all separate components. And if I were to ever move this, I'd want it to move it all as one. And I must have made a mistake. Let me redo or undo. There we go. Undo. Okay. So I want these to move all as one. So I'm going to expand open this mini brushed motor, and I can see all of the individual components. And again, this came from another CAD system. They might have created it in Pro-E, in Inventor, SolidWorks, who knows. But I can see that it's broken down into a bunch of different things. Now there's this gear. Well, I want the gear to be able to rotate, so I don't want that to be rigid, but I want everything else to be rigid. So check this out. I'm going to select all three of those guys, and I want it to be rigid with the gear base. So I'm going to capture the position here real quick, and then I'm going to come in and say rigid group. So it's going to take all of those. In fact, let me just do it this way. If I said rigid group first, I could come in and say this guy, this guy, this guy, and the base. And it's going to take all of those and make them rigid. So now if I try and grab on this motor, you can see that it's not going to move. It's basically locked to this plastic part. However, this gear I can freely move. So kind of a cool way to group things together. Instead of doing one at a time, I can just select all of them and say create a rigid group. So like I mentioned before, this gear is a little bit too high, but I can see it also has like this little plastic standoff. Sorry, it's kind of hard to see right there. So I want to remove that. Because in my design it actually doesn't have this little plastic bushing or this plastic standoff. So like I mentioned before, because this is a inserted part, it has this little link icon, and it won't really let me change that unless I were to open this in another session. So if I said open, you'll see it'll bring up a new tab, and we're now just working on the mini brushed motor. So this is how you used to have to do it. Okay, well, we added this icon right here, this edit in place. So I can actually click on this edit in place icon, and you're going to see right up here it says we're editing the mini brushed motor. You can kind of see it makes it active, and I'm able to do things right here in my design, so I can use information from my other parts, which will really help me. So all I care about, I'm going to just turn off some of this stuff to simplify my design. Actually, oh, sorry, I've already updated it. Oh, that sucks. Sorry guys, when I was practicing it, I already updated it, so I will show you what I did. There was a little plastic piece that came down, but you can see, oops, I can just click on like this face right here and do, for example, a press pull. And I was able to take the existing plastic piece and push it up to match this face. And I know this is a really bad example, but because I practiced it, it saved it as version 2. Sure enough, there it is. So let me try something here really quick. Sorry, let me back up here. And let's do this. I'm going to expand this open. Yeah, see, that just says open instead of insert into current design. So I can promote this guy. I'm just going to do this really quick so you can see what I'm doing here. And let me go ahead and grab the latest version of this. So I'll say, ooh, no, I don't want to do that because everything would update. Sorry, guys. I'm just going to leave it the way it is. So, shoot. Okay. Let me turn these guys back on. So basically what I'll just kind of refresh. There was a piece of plastic that kind of hung down here, and I just edited it in place, and I made that change. So I'm going to go ahead and maybe change it a little bit differently so you can see how this works. Oh, there we go. So we can kind of see. So there's that little plastic piece. I can grab this face and say extrude or press pull. And you'll see as I go like this, it's going to cut away. And then I just selected one of these faces. And I'm just basically removing all of that plastic. And I went ahead and said OK. And I'll say finish, edit in place. And I was able to modify that gear. Now, the next thing I want to do is position the little tiny gear in the correct location. So let's do motor gear assembly. I'll make sure this is my active component. And the reason I'm doing this is you'll notice that I have like a joints folder right here. And I like to have all of my joints kind of at this top level, or at this level of this assembly, right? If I had made this my active part, my joint might show up underneath the tiny gear way down here, which kind of makes it harder to find, for example. So I like to put my joints that kind of define the motor gear assembly right underneath the motor gear assembly. And I do that by activating that component. Okay, so let's go ahead, and if I were to grab this little guy, you'll notice there's no interaction. So I'm going to create an as-built joint because it's in the correct location. So I'm going to say as-built joint, and I'll say between this guy and the shaft here, we'll change it to be a revolute joint. And so it's asking, what are you going to revolve around? So I'm just going to pick like a circular edge, and we can see that it's going to revolve around that edge. Okay. So I'll say, let me go OK. And let me edit this joint here real quick. Top of the gear. Usually I see an offset, and I'm not seeing my offset, which is weird. I'm not having much luck today. Let's try doing something else. Give me a second here. Oh, I know what I did. Okay, I make mistakes. I said let's use an as-built joint, and that's because it's assuming it's in the correct location. In reality, I should have done a regular joint. So let's do this again. What part? So I want to do a revolute. So the first component is going to be this guy here. In fact, let's move this off just so we can kind of see what's going on. I'll capture that position, create a joint. I'm going to say I want to go from that edge there to like this circular edge here. Okay. Maybe. Oh, sorry. Let's do, there we go, to that edge there. And here is what I was talking about that I was looking for, were these offsets. So you'll notice I can move this gear down. So as built, it assumed it was in the correct location, but now I can come in here and specify exactly where I want this, oops, to be. So I'm going to say minus 0.1 in this case. I can also rotate this slightly. So let's look at it from the top and rotate this so it's kind of meshing like so, just so we get a couple teeth meshing. Okay. Now if I try and grab that guy, it should let me rotate, and it's not. This is great. Okay, well, we'll move on and see what's going on here. I'm not 100% sure why it's not rotating, but I'm going to create a motion link and see if that lets me do this. So now I'm going to go to Assemble, Motion Link, and oh, there we go. The answer is right in my face. It's because it's a rigid joint. Even though I changed it, let me go here, say revolute. Okay. Kind of take a look. Let's make sure that those teeth look pretty good. Yeah, okay. Now if I try dragging this, it'll revolve. Man, I'm stumbling a little bit today. I apologize, guys. Okay, now obviously the gear moves, but it doesn't interact with these other gears. So we're going to come in and do a motion link, kind of like what we did with these other gears. So I'll say I want to link between that revolute joint and that revolute joint. Okay. Now obviously this guy is going to spin pretty fast because it's smaller, and this one's larger. Now, on last week I said I don't know the math on how to do gears and all that kind of stuff, and a lot of people chimed in and said it's just the ratio of the number of teeth between one and the other. Again, that's awesome if you guys know how to do this. I'm just doing trial and error. I could calculate the ratio or whatever, but I'm just going to come in here and say for every 360 degrees that this guy rotates, I want the bigger gear to only rotate about 75 degrees. So I'm going to go ahead and say OK. And then I like to kind of preview and start to rotate like so. And sure enough, we can see that those teeth are pretty close. You know, they're engaging like so. And now I'm going to zoom out so you can kind of see what's going on here. As I rotate this little tiny gear, we can see how all of these gears interact and how it's rotating that large gear fairly slowly as I'm rotating this little motor gear way down here. Pretty cool. Okay, so I'm gonna revert back. So the next thing I want to do is we're gonna create those little standoffs that kind of hold this motor in place. So again, making sure my motor gear base is my active component because I'm going to be working just on this plastic part. Okay. And I'm going to create a new sketch. And then I want to grab information from my motor. And I don't know if you can see this really well, but there's like this plastic part in there that the motor kind of gets trapped inside of. Hard to figure out on the camera, but you can kind of see what that looks like. So I'm going to go ahead and do that. So P for project. P is the shortcut key. And I want to make sure I'm projecting the whole body. So I'm going to come over here and say body. And then I'm going to rotate slightly so I can kind of see what's going on here. But you'll notice if I kind of hover over this motor case and press OK, it's actually going to project that whole motor onto my sketch. So I'll go ahead and say OK. And to see this a little bit easier, I can turn off the motor, and we can see that outline. So we're using information from the 3D model to help us with our design. Now I'm just going to create that plastic extrusion, so one of the easiest ways of doing this is just to offset this guy here, and you can see that it's going to take that whole chain and offset it. So let's do 0.03. I'm going to bring up the drawing really quick so you can kind of see the information. Whoops, tried to zoom. Let me bring this down here. So here's the thickness, the 0.03. And you'll see we're going to be adding some chamfers. I'm going to have some hole locations. So this is kind of the thing we're working on right now. Okay. Okay. So offset that. I'm going to click on this and say extrude. And according to the drawing, it is 0.3 in height. And we're going to join that to this component. So we just kind of created this little cradle for the motor to fit into and kind of keep it from turning and holding it in place. Now I want to create those post holes, so I'm going to edit that last sketch. I'm just going to come in here and say edit. And we basically want to create, let's take a look at the drawing one more time here. There's some notches in here, and let me kind of scroll up and over so you can kind of see there's these tapered notches in here that kind of allow the motor to fit into there a little bit easier. So we're going to create that, and to do that we're going to create a 0.25 wide triangle. Now this is pretty interesting. We're at a weird angle and I want to create a center rectangle, so I'm going to say rectangle, center rectangle, but you'll notice it doesn't let me set that angle. Okay. However, if I say rectangle, 3-point rectangle, I can click a couple points and it'll let me set that, but it's not perfectly centered. So which one should I use? Well, I like to do the center rectangle. So I'm just going to click on the center. I'm just going to draw a shape like so, making sure I'm not snapping to anything. I'm just going to go ahead and click it like that. And as we look at the constraints on this, we can see that these are parallel constraints. So this line is parallel with that line. This line is parallel with that line. This one means it's 90 degrees. And you'll notice right here is a horizontal constraint. So I'm going to click on that constraint and then hit the delete key on my keyboard. Now it's still a centered rectangle, but I can change the angle of it. It's still staying 90 degrees, parallel with each other, etc. So what I want to do now is I want this top edge to kind of match this top edge right here. So we're going to use the collinear. So you might say, oh, do a parallel. Well, parallel would work. It would make it parallel to that line, but I want this to actually be right on that line. So that's what collinear does. So I'm going to say collinear. I want that edge to be collinear with that edge. And now you can see our rectangle is still centered and it's at the correct angle. So the last thing I need to do to fully constrain this is to dimension the width. So I'm going to click on that edge. Now you'll notice as I move away, it starts out as an aligned dimension, but as I move away, it kind of switches to a horizontal dimension. I can make sure it's aligned, or I could right mouse click and say I want it to be aligned. And now no matter where I move, it's always going to be an aligned dimension. So I can place it there and say 0.25. That updates. We can see that it's fully constrained. Now when I said finish sketch, it went away. And that's because it's turned off from the last thing that I did. So all I have to do is turn it back on. So I'm going to go ahead and select these 3 profiles. So you can kind of see they're kind of buried by this extrusion. So I'm going to click and hold for about a second to get this little thing that pops up. It allows me to kind of probe through. So the first thing it hits is the face. The next thing it hits is my profile. So I was able to select my profiles. Now some of you might say, well, all you have to do is select these 2, right? Well, yeah, you're correct. But what if you come back and change like draft angles or something like that? So again, I like to over exaggerate and almost imagine like, you know, a cutter is coming in and cutting through here. So I'm going to select all of these profiles, say extrude. How far? To object. And I'm going to click this top face right there, and you'll see it's going to take that profile and extrude it up to that face. And again, to object is really cool because if we were to change the height of this standoff, it would always extrude this cut to wherever the height of that standoff is. It knows it has to go to the top face. So there we go. So instead of typing in 0.3, I'm always going to say to object. I'll turn off that sketch to kind of simplify things. So the next thing I want to do is add those angled faces. So I like to use the draft command to do that. So let's do modify draft. Okay. I'm going to start simple and then we'll do all 4 faces. So the first thing it asks for is this pull direction. And a lot of people try and say, well, I'm not pulling anything. The way I think of it is, where is my hinge going to be? So if I wanted this face to kind of taper out, to grow at the bottom, but I want it to hinge along this edge right here, this is going to be my pull direction. So check this out. I'm going to click that face as my pull direction. Then I'm going to click this face, and you'll notice that it hinges around that edge. Okay? If I had said this is my pull face, you'll notice it now hinges around that edge. So that's what that pull direction means. So I want to say this is my pull direction, this is my face, and I want it to go 5 degrees. Now I can also come in and add other faces, such as, let me do that face there and that face there. You can see they're both going to taper, or draft I should say. I can do all 4 of these at the same time, and they're all hinging on that plane. Okay. The next thing I want to do is add a chamfer. Now, hopefully you saw, we just pushed out a release, I think it was Monday. We added some really cool new functionality to the chamfer command. If you haven't seen that, check out the what's new in the question mark in the upper right, and I'll show some of it right here. But in previous versions, you couldn't chamfer like you can with fillets, for example, but now you can. So for example, I'm going to click on this edge and say chamfer, and you're going to see my chamfer dialog looks a little bit different, and we have these new corner types. So the regular chamfer, miter, and blend, which is really, really cool. So if we have time at the end, I'll show these, but I'm going to continue on here. I want to do, instead of an equal distance, I want to do 2 distances. So I'm going to switch to 2 distance, and what this allows me to do is I'm going to start to drag to kind of see what that looks like. And you can see I can have 2 different distances. So on the first, let me just make this a little bit larger so it's easier to see. So on this first one, I'm going to say 0.02, and on this other one, I'm going to say 0.04. So what it's basically doing is it's going in 0.02 in that direction and 0.04 in that direction. I'll go ahead and add in this other edge over here, and we can see we kind of made a nice tapered guide for our motor. I'll say OK, and there we go. Again, check out the new chamfer command. I'll probably highlight it in an upcoming live stream. So, okay, the next thing I want to do is position those posts. So I'm going to turn my motor back on so I can kind of see what that looks like. And I'm going to edit my last sketch. So again, my motor base is active. So I'm going to edit my last sketch. Now I want to create some circles that are in the same direction as my motor and are equally spaced. That could be a little bit difficult. So I'm going to use some construction geometry to help me out. So I'm just going to create a line. I'm just going to draw a line. I'm making sure I'm not catching to anything. I'm just going to do a line something like this. Just a random line. I'm going to change that to construction geometry. And here is where I can come in and say, I want it to be parallel. I want it to be in the same direction as my motor. So I'm going to say parallel that line with that line there. Oops, make sure I click on it. There we go. And a little hard to see, but you can kind of see that that line is now in the same direction as the motor. Then I want to make sure that it's centered. So again, I'll use a constraint to do that. We'll use the midpoint constraint. I'm just going to click somewhere on this line and then this center point right here, and you're going to see that it moves that line so it's perfectly down the center. If I grab one of these circles, they both change because it's a midpoint line and it's parallel with that edge. So that's perfect. Now I have a place to put these circles, so I'm going to just click on this endpoint and 0.2 for the diameter. I'll do the same thing over here. I'm just going to randomly click a size and say I want those two circles to be equal. So I use the equal constraint. So whatever this circle is over here, that circle has to be also. And then finally, I notice that they're still not fully constrained. If I were to drag on this point, I can see, I can kind of change the width of that line. So let's throw a dimension on that line. Again, I want to make sure it's aligned. So I'm going to right mouse click and say aligned, like so. And I want that to be 1.2. And you can see that those circles kind of updated. They are fully constrained. So I now have those exactly where I want. Okay. Hopefully that makes sense. I'm going at a little faster pace because a lot of this is stuff we've done in previous live streams. Now, here's where I'm purposely making the mistake, so don't freak out. I'm going to say extrude, and I'm going to, again, say to object. So I'm going to say to the object, I want it to go to this top face right here, this flat face right there. I'll say I want those to join. I'll say OK. So the next thing we're going to create is this little motor cap, is what I'm calling it. So let me jump to, oh yeah, and here's the dimensions for the new hole locations. So you have those according to the video that I've been doing. This is that little motor cap. Pretty simple. And so we're going to create this part next. So it's a separate component. So I'm going to right mouse click in my motor gear assembly because I want it to be all part of this. And I'm going to say new component. I'll call it motor cap, and we'll see that it's going to put it underneath my motor gear assembly. In fact, let me minimize the motor. So here's the motor cap underneath. You can see that it's active, which is great. And now I'm going to create a sketch to kind of define that. So let's just put it on this top face right here. I'll create a sketch. I'll go ahead and turn off the motor. We don't really need to see it right now. I want to use the information, so I'm going to, in fact, I'll rotate so you can kind of see this. I want to project these little pillars onto my sketch. So I'll say OK, and we can see that we've projected those onto my sketch. Now I can use these to create the rest of my design. So I'm going to kind of do it isometrically so you can kind of see what's going on here. So I'm going to create a circle there that's 0.45, or sorry, 0.9. I lied. Give me a second here. Circle. Okay. I'll go here. Draw a 0.9 diameter, and I'll repeat a 0.45 diameter. Oh, I'm sorry. Again, rushing too fast. I forgot to project the motor hole. I need this location right here. So I'm going to project that guy. This makes more sense now. Now when I say circle, I can do the 0.9. I'll repeat to create a circle again. I'll say 0.45. This is going to allow room for the motor. I'll create another circle over here. And these guys, 0.3. This makes more sense now. And 0.3. Okay. So I kind of have the basic shape. Now the next thing I want to do is connect these with lines. And I've shown these in other live streams. My favorite way of doing this is if you just hover over a circle and then click and hold, you'll see that it's creating a tangent constraint for me automatically. Then when I come over here, I just need to move until I see the tangent constraint appear right there and drop it. And you can see that it created a tangent from this circle to that circle. So let me do that again. Click and hold. Come over here until I see that tangent constraint. I could even, instead of starting from the big circle, let's start from the small circle. Come over here until I see the tangent constraint. And same thing over here. So I just find this really fast, kind of a fast way of doing that. So we now have the basic shape of our motor cap. Let's go ahead and extrude this guy. So I'm going to look at it from the side, and I'm just going to draw a selection box around that whole thing. Okay. Now I want to keep this opening right here, so I'm going to unselect those two. And I can right click and say extrude. Oh, that didn't do it. Sorry, let me try that again. Let's try the extrude first. So I'm going to create an extrude, and then I should be able to draw and grab everything. Yeah, that's probably the better method. There we go. Start the extrude command first, and then I can draw all the way around. Now, why did I do that? Well, notice it says 9 selected. So if I hadn't done that, I'd have to click this region, etc., which is a lot of mouse clicks, right? Well, by drawing a selection box around everything, I only have to unselect the 2 regions that I don't want to extrude. So a little faster to do that. Okay, I want to extrude this 0.08, I apologize, 0.08 up. I'll say OK. I'm going to reuse that sketch. So let's activate this, turn this sketch back on. And now I have these regions. And I want to make sure I'm extruding all of it. So I'm going to grab that profile. And no, actually I lied. I only want this outside profile because we want it to slide over the shaft there. So I'm going to say extrude. I'll start to drag to kind of get a preview of what that's going to look like. That's in the negative number, so let's go minus 0.125. I'll say OK. And then I want to add some draft to this. So modify draft. Again, it's asking what is my pull direction. Well, I want these faces to be tapered, so I basically want it to hinge around this edge right here. So my pull direction is going to be that face. Then my faces, I'm just going to go ahead and click here, and you can see it chained around and grabbed all of those faces for me. And I can now come in and add either positive draft or in this case negative draft. So let's do -5 degrees. And really quickly we created a drafted part. Okay. I'm going to go ahead and create a hole on this top face. So I'm going to say hole. I like to kind of click out here in space, and then you'll notice as I drag this blue dot, other dots appear. And so I can actually place this hole right at the center. Now, I'm going to change the size of it real quick. Let's just make this 0.1 so you can see a little bit better what's going on. Now when I drag, I'm just going to drop it right there, and it's perfectly centered around this arc. Then I can come in and specify like what kind of hole it is. So I want it to be a simple hole. Simple, not tapped. I want it to come to a drill point, like so. I can specify the diameter, in this case is 0.1. And then for the depth, I want to do 1/2 inch. So I'm going to say 0.5. Now you'll notice it looks like it's previewing that it's cutting through both of these objects. Well, check out right here, objects to cut. If I expand that open, sure enough, it's cutting through the motor cap, which is this top part here, and it's cutting through the motor gear base at the same time. If I were to turn that off, it will not cut through the motor gear base. It'll only cut through the motor cap. But I want it to do both. And I think this is really cool. So instead of creating the holes in here and then creating the holes in here, we're kind of doing a late downstream process where we're kind of drilling through both. I'll say OK. And you can even see in the preview that it drilled through both. I'll repeat that. It remembers my last settings, which is really cool. So I'm just going to drag right there, 1/2 inch deep, 0.1 in diameter. I'll say OK, and we've just created holes for the screws to go down into, all the way into this part here. Okay, now I'm going to turn the motor back on. And here is the mistake I was telling you about. Notice that this is not sitting flat on this face, and that's kind of what we expected to have happen. Okay, for whatever reason, I accidentally, on purpose, picked this top face here and extruded up and built everything off of this face, when in reality, it should have been this face. And the reason I'm showing this is because I see this all the time with customers and on the Facebook group where people get way down in their design and then they realize they made a mistake and they start all over, or they totally mess up their timeline trying to fix it, and they do what I call the hack and whack method, where they're just, you know, adding more material and removing the extra material, etc. So what we're going to do is we're going to go back in time. We're going to fix this, okay? So I want to make sure my motor gear base is my active component, okay? And this extrude right here was kind of my last extrude. And isn't this cool? There's those hole commands right there that got added into my motor gear base. But this was the last extrude that I did, and I can hover over it and I can see that's the case. So I'm going to double click on that to edit it, okay? And it remembered all of my settings. Well, the thing that we want to do is we said to object, and we clicked that face. Well, I want it to be this face instead. So I'm going to hit the little X next to to object. And instead of picking that face, I'm going to pick that face. And you'll notice that the pillars, is what I'm calling them, now only go up to that surface. I'll say OK and check out what happened. okay? Because if you remember the steps that we did to build this motor cap is I created a sketch on the top face of this pillar. Well, because that pillar moved down, so did the sketch. So did my extrusions and everything like that. And even my holes are still 1/2 inch deep from this face. So instead of doing what I call the hack and whack method, I think it's really a good idea to go back and fix what you can in the timeline. Okay, we're going to run over as usual. So the next thing I'm going to do is we need to somehow mount this cap to the part. So I'm going to insert a McMaster car component. So I'm going to say insert McMaster car. To speed things up, I'm going to show you a really cool trick. I could come in here and say screws and bolts and then pick on which, set all of these things. But I actually know the part number for the screw that I want, which is 91772A110. And I'm going to just search for that. And you can see it, sure enough, it finds it. It actually highlights it right here. So it's a 1/2 inch, fully threaded, 440, etc., etc. So you can also search for the part numbers like you see right here. So I'm going to click on a step file, and it's going to bring this McMaster car component into my design. So you can see there it is. Now we're actually looking at the bottom of the part, so I'm going to flip this over like so. Make sure it's at 180. And just like I did before, I'm just going to do a point to point. So I'm going to grab that edge there and this edge here, and it's going to position that screw where it needs to be. And I'll go ahead and capture the position because it's where it needs to be. So I'll say OK. There we go. I will also find this. I'm going to go ahead and click on it so it is underneath. If I click on the face, it's underneath the motor gear assembly. Let's click on this guy here. There it is. So I'm going to right click and say copy. And then I'm going to right click and say paste. So instead of having to go into McMaster car and search for it again, I'm just going to copy and paste. I'll do my point to point again. So I'll grab that bottom edge. I'll grab this top edge. We'll say OK. And now I have the 2 screws that I want. I could even move these out of here and put them just under the motor gear assembly. So they weren't part of the base. They're right here. So we've got that whole thing assembled. Okay. The last thing we're going to do is the last component. There is a shaft that fits into this groove right here, and it connects with the cutter. You'll see there's a groove shaft there also, or a hole for it. So we need to create that. So again, under the motor gear assembly, I'm going to create a new component. And this is a pretty simple part. It shouldn't take very long. And I'm going to call this drive shaft. I'll say OK. So we now are creating this drive shaft. I want to make sure that my gears are displayed. I also want to turn on the cutter assembly because we're going to reference that. And then I'm just going to create a quick sketch. So I want it to basically sit at the bottom of this groove. So I'm going to click on that face and create a sketch. Then we're going to create a circle. Again, I'm kind of rotating isometrically because if we look straight down, it gets kind of hard to see with everything kind of in the way and stuff like that. So I'm going to rotate so I can kind of see what's going on. I'm going to click that center point, and then I'm going to click this outside edge of this circle right here. So you can kind of see like that. I'll finish my sketch. Now there's multiple profiles here, so once again I'm going to click all of these by clicking and holding. I'll say extrude. How far? Instead of a distance, I'm going to say to object, and we're going to pick the inside bottom of that guy. And so in this case, it's 2.09. You can kind of see that, but we're just taking that circle and we're extruding it up. And that's part of the drive shaft. Well, these are kind of weird shaped holes, so I'm going to use the combine command. What's my target? This is my target. What's the tool? The tool is going to be this gear. Now by default it wants to join them together, and that's not what I want to do. I'm going to say cut. And it's kind of hard to see what's going on here, but it's going to use this gear to cut away basically this keyway for this slot to go into, this shaft to go into the slot. Also notice it says tool bodies. I can select more than one tool body to affect the target. So I'm going to come in here and say this guy also. So we're using this gear and this cutter assembly to define the shape of the shaft. Now, I definitely want to keep my tools. If I left that unchecked, it would actually remove that gear and it'd remove that cutter, and we do not want that. So I'm going to say keep tools. I'll say OK, and we now have the shaft that's keyed perfectly to fit inside of those. Okay. Last couple steps here. I'm going to activate this guy and show you an issue I ran into and how I came about resolving it. So I now have this shaft. Let's go ahead and I'm going to create an as-built joint for this and this because they're basically press fit together, right? So I'm going to come in and say as-built joint. That guy and that guy, I want them to be rigid with each other. Now if I grab that gear, we can see how, sure enough, the slot up here is rotating because this is press fit in, it's rigid. That's great. Okay. Now I want to kind of do a top level assembly or joint now because I want this to affect this guy, and it's hard to kind of see what happens here, but as this shaft rotates, this whole assembly rotates in this cap right here. Remember we created that toothed gear or something like that in the I can't remember what it was. I'm sorry, it was in part 4? Yeah, it was in part 4. So it basically revolves around inside this part right here. Okay. So what I want to do is connect these guys together. So I'm going to create an as-built joint between the cutter assembly and the shaft. So I'm going to say this and this. And I want it to be rigid also and say OK. Because this shaft gets pressed into this part. Well, now I'm going to grab this gear and try and rotate, and you'll notice that nothing happens. I'm trying to rotate this gear and nothing happens. And this happens a lot. I see this a lot with some of the customers I help out with. So one of the things I personally recommend doing is, I'll bet you we created some joints previously, and that's kind of locking things up. So what I'm going to do is expand open. Here's my top level. Here's my top level joints. And I've got a couple rigid, some sliders that we did. And then this is that last rigid joint that I just created. So I'm going to select these joints here, right mouse click, and suppress them. So I'm going to say suppress. You'll notice they kind of turn gray. And when I suppress them, you'll also notice it gives me the option to capture the position or to revert. Now, why is that? Well, these were kind of defining positions. So for example, the slider might have defined where this was up and down in the whole assembly. But by suppressing that, it might jump back to its original location. So what this is allowing me to do is to capture where this is at this point in time. And that's exactly what I want to do. So I'm going to say capture position. And you'll notice nothing moved, nothing slid up or down or whatever. So by turning these guys off, I'm still okay. We use these to position the parts, and we used the suppress feature to capture that in time. Now if I grab this gear, I can see that sure enough, that enclosure, or what, this part here, rotates, but the cutter inside of it does not. But by unsuppressing these, I was able to rotate and get the result that I want. So now I'll go ahead and fix this really quick. Because they're in the correct location, I can come in here and say as built joint. I want to, I'm going to do a revolute between this guy and this guy here. And then I'm just going to rotate it around like a circular edge. I'll say OK. If I were to rotate this gear, we can see that the cutter now rotates with that housing. But in reality, this is going to get spun around by that internal gear tooth. So we're going to do a motion link. And I'm going to motion link that with this guy here. So we're basically going to say every time this revolves once, this is going to revolve a ratio, a gear ratio of some kind. Okay? So I'm going to stop the animation. So for every 90 degrees of this large gear, the top gear is going to rotate faster. Okay? So let's say OK, and let's just test this really quick. I'm going to rotate to the right, and sure enough, you can kind of see how as I rotate that gear, it's rotating the cutter, and that's what actually sharpens the pencil. And again, I just picked 90 degrees. It might have been something else. You know, it could be 65.5 degrees. Who knows? But just to kind of show the idea of this revolving around. If I turn on part 4, so it's, you know, meshing with that gear that's inside there, and this part stays put, this part rotates, so that's how it sharpens the pencil inside. Okay, let's show all components. We are pretty much done with our design. Let me jump back to my camera. I mean, I could do a part 11 on like how to create an exploded view. I might do that down the road here a little bit. I'm not going to do every single thing. So for example, there's some wiring in here and stuff like that. This was more for the modeling side of things. So I'm probably going to stop here. Like I said, I might continue on down the road a little bit with some more stuff, but we went from absolutely nothing to reverse engineering these parts to the finished product that you see, you know, on the screen. So have fun with this. Add some materials, create some realistic renderings, maybe create a drawing set of it or something of each of the parts. But I'm leaving it up to you where you want to take it from here. So hopefully you have found this series beneficial. I've even learned a lot of stuff doing this. I learned I can make lots of mistakes, but I thought it was kind of cool showing how do you go back and fix those mistakes. And you saw today how we were able to reposition those posts and everything updated across multiple components, which just blows me away. We were able to move the gears around. We were able to create that motor cap, and I realized, oh, I started it in the wrong location, and it updated everything just by going back and changing how tall or where we were extruding those standoffs to. So with that, I want to thank Angelo for helping out. If you have any questions or comments, please feel free to post them in the YouTube channel. We do read those. If you have any ideas for upcoming live streams, we value those also. I think my next live stream I'm going to do is called, how would you make that? I had a customer send me a drawing, and he's like, I don't even know where to start. So I'm going to show how would I go about creating stuff like that particular part, for example. So if you have other ideas, other drawings, other examples, let me know. And we love doing these. Angelo's doing the cam series, so keep an eye out for those in upcoming live streams. And we will see you next time. Have fun fusioning.